Hello, good morning, everyone. Welcome to another ONOS TST meeting. And today's meeting is going to be, the sole item on the agenda is designed for the AI-assisted automation framework that was first presented last month by the Samsung Research Institute from Bangalore. And we're going to have a little bit of a lighter attendance today because a number of team members are preparing for the P4, and there's a few other events and demos that the team is busy preparing for. But we're going to record this and upload it onto the YouTube channel for ONOS. So without further delay, I'm going to pass it over to you, Senthil and Karthik. And please take it away.
Yeah, thanks, Thomas. Zishan?
Hello, everyone. So
content is shared. Yeah.
Yes, content is there. Can you?
Yes.
Are you able to see?
Yes, I can see it. Yep.
Okay. Oh, great. So my name is Mohammad Zishan Monabi. I'm a senior engineer at Samsung Research Institute, Bangalore. And today I'm going to be the host for this meeting. I'll present the slides along with a friend of mine, Sudhakar. So let's get started. So in continuation with what SRIB presented on 20th of April 2022, the AI assisted automation framework proposal, we have done some work in continuation of that proposal, and this is the development plan that we have come up with. We have developed, our plan is in 3 phases. So currently, phase 1 is for the flow collector integration in ONOS, where we are going to collect the flow information from the exporters. Basically, these are the routers and switches in the network, and we will parse and we will collect it, we will parse it, and we will store it. Thereafter, phase 2 is for the AI ML engine integration with ONOS, where the AI ML controller will fetch the records from the store, and then it will train its models and create a prediction model and stuff. And then phase 3 will be the later point work, where we will bind everything together and we will propose an end-to-end solution. So currently we are planning to work on 1 and 2. These 2 phases can be worked upon concurrently. So we are doing it right now, and phase 3 is for a later point of time. So this is the pain point that Samsung Research Institute Bangalore is trying to achieve with this proposal. This is for basically will be a big help for the telecom operators. As is the current scenario right now that we do have in ONOS is the operator has to be operator has to manually screen the traffic in the SDN network, and has to take care of stuffs like deployment and check abnormalities and intervene to correct those if some abnormal stuff happens. But there are some very clear drawbacks that the operator faces during the task, like they have to manual screening is very cumbersome because there is a huge amount of traffic that flows through the network, and the traffic condition also varies dynamically, and the operator has very less time to pinpoint the issues and to take any corrective action required for that. So our target with this proposal is to do away with the manual intervention of the operator as much as possible, and to create an automation framework. So this is what we are planning to achieve. We will gather the traffic statistics from the devices across the SDN network. We will study the traffic characteristics and create in terms of traffic flow and abnormality and any stuff that is of interest to us. And then we will use a time series forecast analysis, where we will try to optimize the resources that the network is using. One potential use case that we are trying to achieve is power saving mode that we want to introduce in the network, wherein I will explain through this use case on the right. This is the SDN controller, and this is the NFV data center. So what exactly we want to achieve is like suppose we have on the left hand side of this diagram, we are going to have physical redundancy. We might have two servers, each server running one virtual machine, one NFV, and there might be a situation that maybe both of these servers, if we consider these two servers, there might be a situation that both of these servers have 5% or 10% resource utilization at point of time, which is too low, and it is I believe it is not worthwhile to engage two servers for such a low consumption. So there could be a scenario where we can move all the traffic from one of those servers to the different server, and the other server might have a 20% load or a 30% load, and we can free one server altogether. We can shut down the server. We can achieve a lot of power saving using that. And on the right hand side of this same diagram, we can see a dynamic scale in, scale out, where we have a single server and we can have multiple virtual machines running on it. We can, based on this automation framework, we can scale out and scale in. We can create virtual machines on the fly based on the resources that our network is using at that point of time. So this is one potential use case that SRIB has thought of, and we foresee a lot of potential in it, because this could be very helpful for an organization or anyone using this system. So let's go to the phase one of this and explain what exactly we have. So phase one is essentially targeted for flow protocol integration with ONOS, and it, more specifically, it is for Netflow version 9 that we are targeting right now. So if we see this architecture diagram, this phase one basically is concerned about the bottom left of the diagram, where we have the Netflow and the traffic flow parser and traffic monitoring provider. But in our BMP, but in our last meeting, in a previous proposal that SRIB proposed, we were told that we should, it is suggested to us to not follow this protocol driver and provider architecture, and instead focus all our and to put all our application in the application layer. So this is what we are trying to do in this solution as well. We will create our solution in such a way that we will put it in the application layer, so that at a point of time, if some user does not want to use the solution altogether, they can switch, or they can disable the solution from the application layer and not touch these intermediate provider, driver, and protocol layers here. So we do want to we are targeting this part of the architecture, but we are doing it, we will putting all our application in the application layer. The whole collector framework and the collector thing, Netflow collector, will be present in the application layer. So this is what exactly, this is what we have thought of right now. But based on the feedback, we are open to alter our design if necessary. So this flow protocol integration, we can depict it like this. We have a flow, a collection of devices. These are mainly switches or routers or any devices that are that have the flow information in the network. So we call it as a collectively, we call it as flow senders. So these flow senders will have, currently we are only following Netflow protocol. So this will send Netflow packets, and we have in ONOS, we will have a Netflow collector that will collect this packet, and then it will store it in the storer and decode and store it in the store. So Netflow protocol is explained in RFC 3954. It's a session sampling protocol. So it statefully tracks flows and sessions, and wherein it aggregates all the packets associated with each flow into flow records, which are then exported, where multiple flow records are exported in a Netflow datagram. So this is what we are trying to achieve, and this is based on RFC 3954. This is one very typical and very simple simplified example of a Netflow packet that we have tried to depict here. This top diagram is a Netflow export packet, where we will be having a packet header and a set of flow set packets. Flow set packets includes template packets and data packets. So packet header will have these very general information like what version of Netflow we are using and how many, and counts, and what is the system uptime and source ID and sequence number and so on. And template flow set is a very important component of this export packet, wherein a template is basically, in this respect, a template is basically a semantic interpretation of the data packet that follows in the Netflow packet, in the Netflow export packet, and it identifies what values we are sending with the data packet. For example, if we can see, we have a template ID of 256, and it says that it has a field count of 5. So it is very very clear by this that this template will have is explaining something that has a field that has 5 fields in it, and then it identifies all the 5 fields. These left hand side is the fields, and these right hand fields depicts the sizes of the fields in bytes. So IP source address has a byte of has a length of 4 bytes and so on. IP destination address has a length of 4 bytes and so on. And there is a direct correspondence between the template IDs and the flow set IDs present in the data flow set. So we have, suppose if we have a data packet that we are going to parse, so we have a flow set ID of 256. Our requirement would be to get hold of a template that of ID 256, and then based on the fields in the template, the explanations that we have, the structuring in the template, we will parse this based on that. For example, the first field is the IP source address, and it has a field length of 4. So the first field here, 198.168.1.12 is the IP source address, and so on. Then we have the number of packets that we are coming is 5009, and number of bytes and so on. So this is a very typical and very simplified view of the Netflow packet that we are trying to parse. This is a basic high-level diagram of the whole Netflow architecture, Netflow collector architecture, Netflow collector component that we are going to design for this solution in phase 1. So this top thing is the set of exporters that we have. Then we have made it in a 3-layer system. We have a receiver layer, we have a mapper, and we have a store. So the task of the receiver layer, the components in the receiver layer will be tasked to accept the datagrams, UDP datagrams from the exporters, and it's the socket buffer. All the packet UDP datagrams that is coming from the exporters will be stored in this buffer. And then we have a flow set extractor and segregator. The task of the flow set extractor and segregator is to extract the Netflow packets from these UDP datagrams and then identify what type of flow set packets are these, and then put it in the respective queues. If it's a data packet, a data flow set, it will be put it into the data queue. And if it's the template flow set, it's put it into the template flow set queue, and then options template flow set queue. So these set of queues are flow set queues. So this is what it is. It will accept the UDP datagrams, extract the Netflow packets from it, and identify the type of flow sets and store it in the respective queues. Then the mapper layer that gets activated, and the task of the mapper layer is to parse these flow sets that is present in these flow set queues. So first, to parse, we have to understand that to parse the data record, to parse the data flow sets, we need to have the templates already stored, because that template explains what exact data we do have and how to interpret the fields in the data flow set. So the first task would be to parse the templates and the option templates. So the template record parser and the options template record parser are the two components that will parse this template and store it into the template store. And when all the templates are parsed, then essentially I'm saying that when there are no more packets in the flow set, in the options template flow set and the template flow set queues, template queues. When there are no more packets there, then only we are going to use the data record parser to parse the data records, and the data records will consult that will reference the templates from the template store, and accordingly, based on the match that I showed you in the last slide, based on the template flow set ID and the template ID, based on that matching, all the records will be parsed, and we will create a flow object that will be persisted in a flow object store. And the next phase, the next AI ML engine will consult the flow, will take objects from the flow object store and train and use it to train their AI ML model and to work on that. So this is the overall very high level diagram architecture that we have proposed for the Netflow collector. And now I would like to request Sudhakar to explain the AI ML engine integration with ONOS. Sudhakar, over to you.
Yeah, thank you, Jason. Yeah, so this phase we will talk about the AI ML engine integration, and for that we will use the MindsDB open source tool, which I will explain later. So next slide. Yeah, so the bottom right hand part of this diagram is this space, and so what we will do here is, so far we have discussed how the data is collected using the Netflow collector tool, and once the data is collected and stored in the application layer, then we will push the data to the AI ML engine via some collector tool, and we will pass the data according to our format. And with help of REST and gRPC protocols, we will push the data to the AI ML engine. So we will store the data here, and we will, with the help of MindsDB open source tool and some other tools, we will analyze the data and we will give the predictions accordingly. So yeah, next slide, please. Okay, so what is MindsDB? So generally in ML, we will feed the data from the database, and we will do the analysis part separately in other environment. So what it does is it will slow our development. So what MindsDB generally is very helpful is it will bring the machine learning part into the database itself. So the database integration will happen very fast, and it will be very easy to integrate with any of the databases available. So, and also MindsDB helps to do some predictions and training inside database itself. For example, we can do time series predictions on the data, and linear regression and classifications, everything we can do in the database itself. So MindsDB is licensed under GNU GPL version, and what MindsDB uses is it uses some other open source libraries like Arima and PMT Arima and those things. So the concept which MindsDB brought here is, so it's called as AI tables. So what it generally means is it will bring the machine learning itself to the existing SQL databases. So basically MindsDB is a MySQL wire protocol, and with the help of some simple SQL statements, we can query and we can get the predictions accordingly after training the models. So we are using this MindsDB in this design, and let's see how the design works. So next slide, please. Yeah, so this is the overall design for the AML integration with ONOS. And in the ONOS side, so far we have seen how the Netflow collector pushes the data. And with help of this analytics provider, we will use the REST and gRPC protocol, and we will push the data to this data layer through this data collector. Jisan, may I take the control?
Yes, sure.
Yeah. Okay, my pointer is visible, right?
Okay. What was the question?
My pointer, mouse pointer is visible, right?
I'm not seeing.
Sudhakar, is it the arrow one or?
Yeah, arrow.
Yeah. Can you move a little bit? I guess it is on near one.
No, that's
one.
Jisan.
Okay.
Okay, no problem. Yeah,
Yeah.
So okay, yeah. Okay, so we will feed the data to this data layer through some data collector tool. So what data collector will do is generally it will pass the data according to the desired format, and it will push the data. Maybe it can be in JSON format or anything else. And whatever the format is coming to us, we will convert it to the desired format and we will push it into this data layer. This data layer, we can use any of the databases available in this current trend, like Hadoop or Kafka or anything, or even MySQL is fine. So once the data is pushed to this data layer, we will create a model template based on the data set. So what model template means is basically there are some different parameters in every data set. So what we will try to do is we will try to cover all the combinations of the parameters and we will create a template for each set parameter. So the idea behind this is whenever the new use case or new application comes in, it can use that particular template. Like I need this particular function on my own. So I have some common functions with other use case. Can I use that? Yeah, you can use that. So we can just use this template for that reference and we can just map, and I will show how the mapping is done. So once the model templates are created, so let's say the new use case is coming in application layer. So use case will contact the analytics manager. So analytics manager generally it controls 3 ports. So one is training definition, another is query groups, another is result store. So what is training definition? So as I have said in model templates, training definition does the same thing. It will have a combinations of different parameters and like on what parameter my function is dependent on. So those logics, we can store it in training definition. And under each training definition, there can be a set of query groups, which the use case can use for prediction purpose. So I have to be more specific. Yeah, you can. Those things are stored in query groups, and it is dynamic, and we can add more to these query groups and training definitions. So with the help of analytics manager, use case can select the particular templates from these training definitions, and he can push the training request with the template. So how, yeah, via the REST and gRPC protocol, he can push those templates to the query processor, which is you can see the flow, it's going to the query processor. So once a request is sent to query processor, it will be mapped to the model templates, and we will get the, okay, you have to train via this template. So we will get the idea further, and we will push that particular template to this prediction layer. So in this prediction layer, as I have discussed before, the MindsDB comes into the play here. So what it will do is based on the query, I mean, like generally here we will use SQL query. So based on that SQL query, it will extract the data from this data layer and it will train the model accordingly. So only based on the query which have been requested by the use case. So once the training has been finished, it will store this particular model in the separate database. So whenever the use case is requesting something via this REST protocol, so what it will do is it will the request will be mapped to this particular stored model and the prediction will happen accordingly. So and also this as the data will be streamed or it will be fed in batches in real time. So there must be a periodic training. So what we will do is we will do periodic training and we will train these models very frequently. And whenever there is a new function coming in, yeah, we will retrain accordingly. So it is done to cater to some seasonality changes, and it will be very helpful whenever the model gets drifted all over. There is some change in our data set. And yeah, so what is Docker and Kubernetes mean? So whenever if some 2 or more clients are requesting the same thing or same model, I'm like 2 or more use cases having the same functions. So in that case, we have to distribute the load accordingly. So what we will do is we will containerize this and we will deploy it in this cloud. So Kubernetes will be helpful to orchestrate the container, and we will use a general ingress load balancer or some round robin techniques to load balance all things. So yeah, so that's it. In prediction layer, we will send the response to this analytics manager via this REST or gRPC protocol, and the analytics manager will store the result in this particular result store. So this result store will be useful for the visualization purpose. The client can see how the actual data varies from the original data, and he can see, okay, the predictions are like this, so I can go for these actions. So for this purpose, the result store will be very useful. Yeah, so that's it from this slide. Yeah, Jason, next slide, please. Okay, so here we're going to see a case study in brief. So it's power saving. So let's say like we have an application called resource utilization, and it has 2 use cases: power management and scale and scale. And those 2 use cases have some common functions between them. Let's assume that. So we are using a general database MySQL, and the data set is collected from the Netflow writer, as Jishan said, and it will be stored in analytics provider. So the format is like this: device ID timestamp and trans bytes and receive bytes. So as I said, there will be two major components, training definition and query groups. And let's assume the training definition, let's take an example, like we have two the parameters which are needed to be considered, or timestamp, transfer bytes and receive bytes and device ID. So for this particular training definition TD1, there can be a set of query groups which the use case can use to ask the predict request. So these are the queries. Let's make it simple. In the SQL query, we have a general selectors and the conditions and the operators. So let's say like we have to predict which time we can go for like we can go for upgrade. I mean, like which time the data flows, the data traffic is very less. So the time will be the major selector here, and the conditions will be applied on transfer bytes or transfer and receive bytes in the second query. And the operators can be minimum or maximum, or always dependent on the use case. And the group by and order by functions. So generally, as it is a time series, we will order by timestamp. If the data is already in time, if the data is already ordered, then we don't need to worry about that. So the group by device ID, we can look more specific into particular device and particular source IP and particular destination IP. So group by will be very helpful in that to train the model accordingly. So using these both training definition and query groups, the use case can request the AI/ML controller via this analytics manager, which will further request via the REST or gRPC protocol. So yeah, after requesting, as I said before in the previous slide, the ML process training and prediction will happen, and the result will be output to use case. Yeah. So yeah, that's it from my side. And later we will discuss about in phase 3 in next meeting. Yeah. So yeah, these are just an extra of all the things me and Jason has said, and yeah. So yeah.
So Thomas, so that's a kind of a logical end of this session. If there are any questions, we will be glad to take.
Yeah, so I have to admit I was a little bit of a hard time following it, probably because of lack of the pointer. So when you were talking about the slide like 3 slides back, it was difficult to follow. But yeah, that one. So the application layer ONOS, this is what's running inside ONOS, correct? And the left side of this diagram is what's running external, correct?
Yeah, Sudhakar, you can take the question.
Yeah,
here.
yes, yeah.
Okay, I just want to make sure as I understood. Yeah, so I definitely didn't follow all of the details, especially with respect to the role of templates and overall, actually, just the data flow. It's probably a bit too fast, so I'll have to think about it. But I mean, I'm not sure really in this particular case, as long as you guys have an idea of what you want to do, this really doesn't, you know, it doesn't really affect ONOS per se or integrity of ONOS. So I think you're pretty much free to explore whatever design you want in the external application. I'm not sure at this point in time I really have a complete understanding to provide any reasonable feedback. I may need to sit on it for a little bit. It's also not
sure, Thomas.
Yeah, it was also not clear to me in terms of where the, you know, with respect to the model templates, and the various use cases, what is going to be kind of model specific versus what's going to be model agnostic. It would seem to me that a lot of the, in order to be able to have some concrete predictions and be able to map it to specific use cases, there'll have to be some model dependence, but at least that's just at the generic high level, you know, level of granularity from my standpoint. But again, this is just spoken without having complete understanding what the specific proposal is.
Okay.
It's
So,
difficult.
so Thomas, we understand your concern. So,
no, it's
this,
it's not a concern. First of all, it's not a concern. I don't really have a deep enough of an understanding to have actually a concern. So I just want to make that clear. So I don't necessarily need you to change anything. It's just right now I'm just commenting on the fact that I wasn't able to follow entirely, and therefore not unable. I'm unable to provide really any meaningful feedback. That's all it is.
Okay. So how we can do is maybe I propose we can drill a detail in upcoming next session.
Well,
if it is okay.
I mean, if you think you can benefit from that's fine. But I guess my point here is I don't think you need to wait for basically for an approval in this particular case. Primary reason for us reviewing the designs of applications or extensions to ONOS is to make sure that the architecture kind of remains unbesmirched. that when integrations are done, that they're done with ONOS, that they're done in such a way that basically it preserves the original architectural intent of ONOS. And so that, for example, you don't put application code, let's say, at the device layers, right? And things like that. Basically just that the architectural tenets are being followed. And I don't think in this particular case, this is at all an issue. As you're extracting data from the devices via the Netflow and SFlow protocols. You're feeding it, you're preserving it in some store in ONOS, and you're feeding it externally to a separate application. And I think within the realm of that particular application, you're free to do as you feel best. So I just want to make sure that you don't feel constrained by having to, get a buy-in on a device, on a design of the external application. That's really not necessary. I mean, it's enlightening to be able to understand what's being done with ONOS, but I don't, for me, but I don't think it's necessarily, for you to have to wait for that. That's all.
Sure. Thanks for sharing your opinion. To touch upon few of your points. So firstly, we have made sure that by introducing this design, there will be no real integration issue with ONOS, and ONOS ecosystem is not greatly impacted by this. So that's the reason logically we have kind of separated. If you see the left-hand side, we have the entire MindsDB tool, and towards your right side, you have the application layer ONOS. So what we have consciously taken a decision is actually we want to enable the ONOS ecosystem users to kind of use their own way of using so for example, we have used MindsDB tool. So tomorrow, the other ONOS ecosystem guy may think that I don't need a MindsDB, I will go for some other tool. So we thought that the interface here, if you can see, there is a REST gRPC interface. We want that to be standardized. I mean, so for this to happen, and also if any disturbance happens to the left-hand side, that is for your MindsDB, if any instability or any other factors are there, it will not affect the ONOS. So this was the conscious decision we have taken. This is point number one. And point number two, maybe Zishan, can you go two sites to your Netflow thing? One more slide, please. One more slide, sorry. So here, this was the kind of opinion shared by Sendil. So when he was discussing about the BJP monitoring protocol, so he was suggested that it's better to avoid the changes in the provider layer, device driver layer, or protocol layer.
Sure.
So we kept that application. What is that Netflow here in the application layer? So the ecosystem usage guys can selectively disable or enable as per his requirement. So these are some of the thoughts we had, and we thought that we will have an open discussion with you. I do understand actually the presentation has been a bit faster, but in principle, what we made sure is actually this, whatever we propose does not, impact the stability in the ONOS. That way we thought about this.
No, I did not have any specific concern regarding that. I was just simply enumerating kind of the, in trying to give you basically the reason for the TST meetings is just to make sure that just give you the reasons for those, for the presentations, and in this particular case I didn't really see any issues whatsoever. So this is fine by me. And as far as the sort of, as long as you kind of define the where the interactions with the ONOS platform will be, and it follows the architectural tenets, then beyond that you're completely free to do as you wish, right? So I just basically wanted to make sure you did not feel the need to have to follow up on every design change in your implementation. That's clearly entirely up to you.
Sure. Thanks for your feedback. Thank you.
I think that's it from my side. Again, you know, since I wasn't really able to follow in full detail the second part of the presentation, I'll have to probably think about it a little more. If there's any questions that I have, I can probably just shoot you an email or ask on a step group.
Definitely looking forward, Thomas. Yeah. So guys, actually, Sendil, anyone else want to have any thoughts we want to exchange with Thomas?
Yeah.
Okay.
Yeah. Sorry. I mean, again, you know, it probably would be. I probably don't have that much value to add at this point in time, but hopefully there will be follow-on conversations as team has chance to review this and provide feedback.
Sure.
Or as you submit, as you submit Gary patches too, there'll probably be additional conversations regarding the specific implementation.
Sure, Thomas. So that's it from our side. Thanks for your time, Thomas, and really appreciate your feedback. And we look forward to kind of make it a successful deliverable. We are fully focused on it.
Sounds great.
Yeah. Thanks again.
Okay. Well, thank you guys for the presentation, and I'll post this recording once it's ready onto the ONOS YouTube channel. Okay.
Yeah. Thank you.
Thank you.
Have a wonderful day. Thank you.
You too.
Bye.
Thank you.